record this. Okay. For the anions, anions are going to be bonus. And so the most important thing is the cations. The cations you're going to have the most points wrapped up in. And so let's just take a quick look at the anion test. What anions are you testing for? What's the first anion?
Sodium.
Well, sodium is a cation. Sulfate? All right. Tell me what is the test for sulfate? What are you doing?
You're taking 10 drops.
Okay, anion solution. So we're going to have an unknown aqueous, right? And then adding what to it? Okay, and then 6 molar HCl. All right.
And a drop of barium chloride.
And a drop of barium chloride. And we should get a white PPT. Actually, you guys did sulfate analysis, right? What's the purpose of the HCl? So if your unknown contains sulfate and you add barium ions to it, we should get BaSO4. And so what's the HCl there for? Somebody remind me. Kelly?
To not interfere with the, like, there's interfering ions. Like,
Yeah, right.
Phosphate.
Right, barium
Then
phosphate.
precipitate.
Correct. What happens here is the phosphate will also precipitate out with barium ion. And will form Ba3PO42, which is also a white solid. And what else? Carbonate will precipitate out with barium to form BaCO3, which is a white solid.
Barium oxalate.
Oxalate, C2O42 minus. I don't think oxalate's one of them, but
Wait, is it a white
Okay.
precipitate? Barium oxalate?
yeah. All right, but the situation with these is if we react the barium sulfate with HCl, what we end up with is generating H2SO4 and barium chloride. And so this is NR. We're going from strong acid to strong acid, right? And so we expect no reaction here with HCl. However, if we react it with barium phosphate, then we should expect phosphoric acid and barium chloride. This is not balanced, by the way. And so we're going from stronger acid, HCl, to weaker acid, phosphoric acid. So if any phosphates generated, they'll be dissolved. We know with carbonates, we're going to form H2O, liquid, plus CO2 gas, plus barium chloride. With oxalate, what would we form? We'd form oxalic acid plus barium chloride. And so these have driving force. Stronger acid to weaker acid. HCl being the stronger acid, and these being the weaker acid. This is the weaker acid. CO2 is the weaker acid, and oxalic acid is the weaker acid. Okay? So this would be positive for sulfate. All right, what's next? Okay, nitrate. Let's take a look at the nitrate test. And what are you adding to nitrate? You take it.
Iron sulfate, iron 2 sulfate.
All right, iron 2 sulfate is a pretty good reducing agent. It's easily oxidized by air. Did you guys get this down, or no? All right, just wait a second. Also called ferrous sulfate. It's green. If it goes yellow, then it turned into ferric sulfate. Yellow is going to be iron 3. Oh, there's a chair there. Are you missing a chair? Yeah, you can just wheel one over. Okay, and then what else? Slowly pour in concentrated sulfuric acid. This is very dangerous here. When you do this, all right, you get the, well, we'll pour in the concentrated sulfuric acid. What are we looking for? We're looking for, this is called the brown ring test. We're looking for brown ring. Brown ring at the interface between concentrated H2SO4. Concentrated H2SO4 is like syrup. You know, it's very viscous. Causes severe burns, so it's not as benign as syrup is. It's very dangerous stuff. And so what you'll do is you don't want to grab, what happens is sometimes people grab the test tube with their fingers. It's going to get very hot. And sometimes they spill concentrated sulfuric on the outside. So what we do for this particular test is we do it in the hood, and we use a test tube clamp, right? Did they talk about that? No? All right, this is what you want to do here. You tilt the test tube at about a 45-degree angle like this. And here we're going to have our nitrate plus our iron 2 ions here. The sulfate doesn't participate. And when we add the concentrated H2SO4, we want to add it drop by drop. And what's going to happen is this concentrated H2SO4 is going to run down the side of the test tube and sink to the bottom here. It doesn't mix right away. And so if you're careful about this, what you want is you want 2 layers like this. A dense layer at the bottom, which is, this is going to be concentrated H2SO4. And then an aqueous phase, a less dense phase here. And at the interface between the aqueous phase and the concentrated H2SO4, you should see a brown ring. And that would be the positive test for this. And so what is the reaction that's occurring here? Well, the brown ring is formed from NO gas, right, being generated. Because what we're going to do is we're going to convert nitrate into what? And so somebody tell me the reaction here. So we got nitrate, and what's that reacting with? Is it iron 2? No, dude, why don't you look in the lab manual? You don't have to guess. No, this is for the anion test. For the anion test, you can use it, right? Does somebody have it? No? Plus iron 2 plus H2SO4 yields what?
A nitrate complex.
What is the formula for the nitrate complex? It's not a nitrate complex, actually. It's a nitrosyl complex, right? Which is NO. Okay, well, let's figure out what are the products. Is it Fe3 plus? Okay. And what else? NO gas. And water?
Yeah. Instead of the sulfuric acid, they had a glucose.
Just H plus?
Yeah.
All right. So this is just a simple redox reaction then. The H2SO4 is to supply some H plus, Although sulfuric acid can be an oxidizing acid, there's a better oxidizer here. What is a better oxidizer? Nitrate and H+. Nitrate and H+ that's a good oxidizer, right? Both of these half reactions occur on the redox chart. Fe2+ goes to Fe3+ plus an electron. And then the other half reaction is 4H+ plus a nitrate plus 3 electrons goes to NO plus 2H2O liquids. And so we can just copy these two half reactions off our chart, and we get this. We need 3, 3, 3. Everything will cancel out. So we get 4H+ plus a nitrate plus 3 Fe2+ is going to yield 3 Fe3+ plus NO gas plus 2 H2O liquids. But NO is colorless. NO gas is a CCG, a clear colorless gas. Nitric oxide or nitrogen monoxide, or nitrosyl is the ligand. And so how do we detect the presence of this colorless gas? Formation of an iron nitrosyl complex. What is the
That's the brown suspension.
That's the brown ring, right? The brown ring consists of what is it? Is it iron 2 or iron 3 that's complexing with the nitrosyl?
Iron 3.
It's iron 3, and then how many nitrosyls?
Just one.
Just one nitrosyl,
You can-
and then we form this.
2+.
Is it 2+? Nitrosyl's neutral.
Oh, it's neutral, but it is iron 2+.
Then it's iron 2+. And so we have to have excess iron 2+. We can't have all the iron 2 be converted into iron 3, otherwise we aren't going to see this complex, right? And so this is going to be iron 2+. Okay, and so this is going to be brown. And this is AQ, right? And so it's just this brown layer. In other words, there's a brown layer at the interface between. You don't mix. You don't want to mix the sulfuric with the water. You know, eventually it'll mix. You want to try to keep it separate, so you run it down the side and watch it sink to the bottom. Okay. And this is very dangerous. This is where, you know, I told you I had a student that got a 3rd-degree burn. This is where she got it. Some sulfuric, concentrated sulfuric. Poured it in too fast. It splattered out, just shot out the test tube and landed on her arm. Okay. Okay, what else? What's the next guy? Chloride?
Yes.
All right, chloride should be easy because,
You just added something.
yeah. But watch out for the silver nitrate. You know, did I tell you about my student who had a job interview right after lab? She had a very important job interview after lab. I didn't know it, and then she came up to me and she said she's been washing her hands for 30 minutes and can't get the black stains off her hand. And I said, well, it's probably silver nitrate. You probably touched it, and it's going to take about a week to come off. And so she was just really upset. But anyway, so if you have an unknown and we add silver nitrate and there's chloride in the unknown, then we get a white PPT. Is that the only thing? Are we gonna dissolve this one in ammonia or not? Huh? Do we dissolve the precipitate in ammonia and then no? Okay, so, well,
I mean, it's
it could be carbonate,
right.
so we got to keep the pH down. It could be bromide, but bromide has a yellow tinge to it, and so I'm surprised. In
It's hurt.
hmm?
Maybe because it's hurting, like it's partially associating or whatever.
No, the reason is because they're keeping it simple. They don't want to complicate things. So your unknown is not really an unknown. Your unknown is a known, and we keep things out of your unknown to make it less complicated, right? And so this is not like a real unknown. A real unknown, you'd have to worry about other things happening, right? But this is not.
So So in this case, you want to keep the pH up.
No, we keep the pH down. We usually add acid. When you in case it's a carbonate or something like that, you know, silver carbonate would be a white PPT. But that's easily killed off with acid. You know, there are. I mean, there are lots of things. This is why you want to know all the potential reactions, so that we can see what all the side reactions or interfering reactions might be in an analysis like this. Okay. But if they're just doing it in one step, then this is a like a baby unknown, you know, not a real unknown. Okay. All right. Well, what's next? Bromide. What's the test for bromide?
6 molar HCl and chlorine and water
All right.
and mineral oil.
Yep.
You did this one before in experiment 18. Do you remember this?
I love this.
Yeah. Did you add? Do we add chloroform to this?
Yeah, we have chloroform.
We add chloroform to this. And so we take this and react it with chlorine water or chlorine aqueous. And what we add some chloroform. Is that correct?
Uh-huh.
CHCl3. And then we get an orange.
No, we use mineral oil.
Oh, we add mineral oil?
Yeah.
All right, we add mineral oil. Mineral oil. We added chloroform in Chem 1A. But mineral oil should be nonpolar as well. But mineral oil is not, mineral oil sink to the bottom of water, or will it stay on top? It floats on top. Yeah, oil on water. And so this is going to be orange mineral oil there after shaking. And so this is what's going to happen. If we have bromide, we got 2 bromides in there. We reacted with chlorine. Yeah, the chlorine is going to oxidize the bromide to bromine. Bromine aqueous is kind of a faint orange in water, AQ. And then we'll get the 2 chlorides from here. And then what we're going to do is we're going to do what's called a solvent extraction. Solvent extraction. And so what that means is we're going to extract the solute from one solvent to another solvent. This works if the solute is more soluble in the other solvent. And so bromine's nonpolar. And so it's not highly soluble in water. But it would be much more soluble in mineral oil, which is nonpolar. Light dissolves light. And so what we do is we pour the mineral oil, you're going to get 2 layers there, and then we cork it and then shake it up. As you shake it up, you know, you generate an emulsion or little bubbles of mineral oil in there that suck in the bromine. And what we want is we don't want to use too much mineral oil. Just use a little bit of mineral oil and then concentrate all that bromine in the mineral oil to give it a very bright orange color. And so what we should get is a bright orange mineral oil layer. And so now this is dissolved in mineral oil. And if it's not too dilute, it should be bright orange. Solvent extraction with mineral oil. All right, what's next?
Iodine, but for the bromine one, it says it's orange for iodine. So does that mean it can also be?
The more concentrated you can get it, the browner it'll be.
Yeah. You need to differentiate it. We're only going to get 3 potential colors: yellow, orange, and purple. And so if it's not purple and it's not yellow, it's orange, brown.
Because the iodine's the exact same thing.
Yeah, iodide is just going to be purple, right? And so if we have iodide in there, chlorine can easily oxidize iodide. And we'd form iodine. Iodine is going to be faint purple color. But if we can do a solvent extraction in mineral oil and then concentrate it, it's going to be a bright purple color. in our mineral oil. Just shake it up. Don't add too much mineral oil, otherwise the color is going to be fainter, okay? Or not as concentrated.
So we're not doing a known then for the anions?
We are doing knowns for the anions. The knowns you just grab off here. Look for sodium iodide.
Oh.
The sodium salts are the best. Okay. All right, and then what else?
And then the last one's carbonate.
Carbonate?
Yeah.
Okay. Take a look at carbonate. Carbonate's easy. Right, because carbonate, you just add some, what?
6 milliliters sulfuric acid.
Sulfuric acid? And what's going to happen here?
You get clear colorless gas.
Yeah, CCG, just effervescence. And so if we have any carbonate around and we add some acid to this, like H2SO4, we're going to get H2O liquid plus CO2 gas plus sulfate in this case. Is that all? Is that all?
You hold the barium hydroxide, hold them out in the test tube.
All right. All right. Then what we're going to do is we're going to test the CCG. And so CCG plus barium hydroxide, AQ. And so what we do is we suspend, this is why our barium hydroxide
That's what.
is always
solid.
contaminated, because CO2 is present in air, so we were going to test positive. But what you want to see is rapid film of white precipitate form on the surface of the drop. If you just suspend the drop there and wait like 10 minutes, it's going to form a film anyway. But you need to see a rapid film develop. And we get a white precipitate on the surface of the drop. On the surface. And so we're going to test the gas. You know, the gas is being generated. This is CO2 gas in the test tube. And then if we have a little drop of barium hydroxide, the CO2 is going to react with the surface of that. And so CO2 gas plus barium hydroxide yields BA,
CO3 and H2O.
yeah, BaCO3 and H2O. This is an example of a Lewis acid-base reaction. This is not a metathesis reaction. All right. Is that it? Okay. So those are the anions. The anions actually are pretty quick, except the only one you want to be careful. Well, actually, they aren't. The iodide, bromide will take some more time and the nitrate takes a little bit of time, but they don't really take all that much time. And it's not a sequence, you know, where you have to separate, centrifuge, and do all this other stuff. But they're pretty easy, actually. Really easy. And it used to be in Chem 1B, we used to make the students memorize the procedure. You know, either they memorize it or they knew the reactions. If they knew the reactions, it was pretty easy. But they used to be tested on it like this. But you don't have to memorize it. You can easily do it. Okay. Now for the report for this, is going to be very easy. The report is one page. You just list the ions that you found. Okay. And then the remaining pages of the report, you know all these observations and equations I wrote? I want you to write those all down and then hand that in with the report. So I want to see the observations and equations for each of the ions, just exactly the same way I wrote them on the board.
Oh.
Okay? Not a lot of people end up skipping them. They skip this step, skip that step because they think, oh, we already did that. But I don't want any steps skipped. You want the equations for the ones you found? No, for all of them. All of them? Yeah. For all of them.
Do you want the equations written or typed in?
No, just handwritten is fine. If you want to type it, that's fine, but you don't have to type it. Just
Having trouble with the
handwrite.
divisions.
Yeah, I just want to see if you have them all. The observations and equations, right? At least if you have, you know, just to make sure yours are complete. That's it.
Still next week, right?
Yeah, officially be due like a week later, right? So next week, but next week on Thursday we have the test, so we'll see. All right? Okay, that's it then.
Oh, is there any abstract about all that?
No abstract, no introduction, no. This is not a formal report for the qualitative analysis.
We just want a list of our unknowns that we had and a
Yeah.
list of the formulas.
Right. The observations, equations, like I had written them on. It doesn't have to be exactly like it, but you